What if I told you that time could slow down or speed up depending on how fast you're moving or how much gravity is pulling on you? It might sound like a plot from a science fiction novel, but this is the reality according to Einstein's theory of relativity. Einstein's theory of relativity comprises two parts: the special theory of relativity and the general theory of relativity. Each part provides a different perspective on the same core idea. The laws of physics are the same for all observers, no matter their speed or direction. Quite a revelation, isn't it? The special theory of relativity, published by Einstein in 1905, revolves around the idea that the speed of light is constant and nothing can travel faster than light. It also introduced the idea of spacetime, a four-dimensional fabric of the universe. Einstein's special theory of relativity also gave us the famous E equals m² equation. This simple but powerful equation states that energy, E, equals mass, m, times the speed of light, c². It means that energy and mass are interchangeable. They're different forms of the same thing. 4 years later, in 1909, Einstein started to think about how gravity fits into the special theory of relativity. This led to the general theory of relativity, published in 1916. The general theory of relativity says that massive objects cause a distortion in spacetime, which we perceive as gravity. Imagine spacetime as a trampoline and a heavy object as a bowling ball placed on the trampoline. The bowling ball would cause the trampoline to sag, creating a curve. Now, if you rolled a marble across the trampoline, it would move along the curve created by the bowling ball. That's how gravity works according to the general theory of relativity. Now, how does the theory of relativity relate to time travel? Well, according to the theory, time passes at different rates for different observers, depending on their velocity and gravitational field. This is known as time dilation. For example, a clock moving at a high speed will tick slower than a stationary clock. And a clock in a strong gravitational field will also tick slower than one in a weaker field. This means if you could travel at the speed of light or near a black hole, when you returned, you'd find that more time had passed on Earth than for you. This is the closest science has come to the concept of time travel. In essence, the theory of relativity transformed our understanding of space, time, and gravity. It tells us that space and time are intertwined into a single entity called spacetime, which is curved by mass and energy. And it reveals that time is not absolute, but is relative to the observer's state of motion and gravitational field. Remember, understanding the theory of relativity doesn't require a genius mind, but an open one. So, the next time when you're gazing at the stars, remember that there's more to the universe than meets the eye.